Ready?
The writing looks
Alright. On this one right here, the problem is limit as x goes to pi over 4 of sin x minus cosine x all over tangent x minus 1. Alright, so the next step we need to do is multiply technically kind of halfway by conjugate, not necessarily. Normally we would do, okay, sin x plus cosine x and then sin x plus cosine x on the numerator and denominator. But this time we're going to do something a little bit different. To get rid of one of our factors, which would be the sin x minus cosine x, we're going to multiply this by a factor of 1. The factor of 1 is going to be cosine x over cosine x. Okay? So then our numerator now is going to be the limit as x goes to pi over 4 of sin x minus cosine x in parentheses times cosine x all over tangent x minus 1
times cosine.
Yeah. Actually, it's going to be sin x minus cosine x because I have...
So you have 1 over tangent equals sin over cosine, and you pop out this cosine equals sin x minus...
So we do the common denominator, we do the sin x over cosine x. At the bottom, you're going to have sin x minus cosine x. After you convert. Okay?
How'd you get that?
What? Okay, when you break down 10 equals the sin x over cosine x, right? Minus 1.
So, in other words, so here, let's say I did sin x over cosine x.
Minus 1.
Minus 1, right? And then...
And you multiply by cosine. When you cross out the cosines and just get sin x
Oh, you
minus
just...
1.
Oh, okay. I get
When you get that, why do you still have cosine?
On top?
No, it's
on the bottom.
You said you multiply cosine x right here at the bottom. So multiply cosine x to this side right here. And if you cancel those out, you only have
sin x, sin minus 1.
Well, technically you have, what, sin x? You have sin x, right?
Minus cosine x.
All over cosine x, so.
What happened to the sign?
No, it's up there already.
Why cosine x at the bottom?
No, it's cosine x.
Why cosine x at the bottom though?
Because it's sin x, right? Over cosine x.
Minus 1.
1. 1 over 1 is 1, right? So it's really 1 over 1.
Okay.
So now the common denominator of this is cosine x, isn't it?
Oh, okay.
So one side by cosine x,
Yeah.
right? And now I have
Cosine
sin x.
Minus
cosine x, right?
over cosine x, but you don't need to sin. But why is the sin x? Why cosine x over?
And technically, really, this is what? This is really sin minus cosine x over cosine x, right? And then times
cosine x.
It's really like this. Okay, sin x minus cosine x all over, right? Sin x minus cosine x over cosine x. Now, right? Times cosine x over cosine x. Technically. Okay.
Sin x.
And then you're going to get what? Or if you want to do it, if you don't want to multiply by cosine x.
You cancel out the cosine x at the bottom, so you get sin x minus cosine x at the bottom. Right?
Well, hold on. I'm going to show you something. You can do it either this way with the 1, right? If you don't want to use the 1, we can say, don't worry about that. And when I divide by a fraction, I multiply by the reciprocal. So sin x minus cosine x, this might be the easier way for you to do it, over 1, right, times cosine x, right? Over sin x minus cosine x.
And then you cancel them out.
You got it now?
Yeah.
Cancel them out. Boom, boom.
Equals cosine
x. I'll put pi over 4 into my cosine x, which is cosine of pi over 4. As the limit reaches pi over 4, and I get radical 2 over 2 because it's really the 45.
I like that.
Yeah, it makes more sense. Does it make more sense now?
Yeah. Use that all over the world.
You understand or do you not understand?
I do.
You do? Alright, so when was pi over 4 was a triangle? 45, 45, 90. Right? It's 1, 1, radical 2. right? The cosine of 45 is adjacent over hypotenuse, so it's adjacent over hypotenuse, 1 over radical 2. With the rationalization of the denominator, it gets radical 2 over 2. That's how I got this answer here.
Oh, okay.
So if you don't, let's just take this back. Let's just scratch this right here and leave it as such, okay? And continue this problem.
What's the answer was again?
Right here.
Mhm.
Radical 2 over 2.
That was the answer.
Radical 2 over 2.
You agree.
Alright, anybody have any questions?
Can you explain the bottom part again? Like how you went from tangent x to
This right here?
yeah to
Okay, so
the
what I
bottom.
did was, here's the original problem, right?
Right.
Sine minus cosine x over tangent x minus 1. But I knew, like Caitlin said, tangent is sine for cosine x,
Mhm. Minus
so
1.
minus 1. But
Mhm.
we know I can use 1 over 1,
Mhm.
1 and 2. So the common denominator is cosine x, then cancel these out, your sine x is left,
Mhm.
cosine x is left here, so sine minus cosine x over the common denominator of cosine x.
Mhm.
Then I take this right here,
And put it into your
and I
original.
put it into the original, right?
Oh, okay.
So,
Yeah.
you understand what I'm talking about?
Yeah.
And then I do sine x minus cosine x over
That.
the tangent x minus 1.
Mhm.
It's the same thing, right? Then when I divide by a fraction, multiply by a reciprocal, which is here, I have cosine x left.
So just write that part right there. Like cosine x, that you scratch out, because that don't matter, right?
Which part? This right here?
Mhm.
Yeah, well, this is the common denominator. I just write it up because I know I need to cancel that. And it stays here.
Right. Why are you messing with that one? All you need is a that one to be common denominator. All you need is that 1/2, 1 over 1 to be common denominator. So you just get, so you can combine the two together. So you don't need to cancel nothing out, don't you?
Yeah, you do because you have because you're finding the common denominator of sine x over cosine x and 1 over 1 and if
Sine x over cosine x equals 10, right? So you
Right.
broke it down, you broke 10 down, so you got sine cosine x. And then 1 equals to 1 over 1. But you, in order to combine those two fractions, you have to have the same denominator.
right, which is cosine x.
Okay, so,
Multiply by cosine x.
but why you have to mess with that one? I didn't do it, mess with that one, right?
No, it's the same thing as doing this. Look, if I did it normal, first, let's do a regular fraction,
Right.
right? 4 over 6
Mhm.
minus 2 over 3.
Mhm.
I know that I gotta have a common denominator, which is 6,
Times 2.
right? So I multiply, this is gonna be 4 6. This is gonna be 2, so it's gonna be 4 6 again, right?
Mhm.
Exactly, you didn't mess with
So
that.
it's 0. I did it. I multiply. I did both.
I know, but like,
I
you did look, I'm saying, okay, this is not a cosine x, right? And this is 1 over 1.
Right.
So all you did was multiply cosine by this one and this one. So you don't need to use that one, right?
Well, I mean, it helps showing how he canceled it out.
Right. I could do it like this. Look, sine x over cosine x minus 1 over 1, right?
Mhm.
So cosine x, right? Cosine x.
Uh-huh.
This one has cosine x already, so it's times 1, right? Sine x over cosine x, right? And this was cosine x,
It
right?
was counting cosine, so I thought you meant like cancel that out so it would be sine x minus cosine of cosine. You know what I'm talking about?
That's what it is, yeah.
No, I thought you meant like this, like this is different, like this is different, this is a different problem. You know what I mean? Like it was like here, sine x minus cosine over cosine. Like this one don't have a cosine.
Oh, no, that's right. I just did it differently.
Okay, this
All right, everybody got it?
Yeah.
All right. Thank you very much.